Hello, everyone. Good to see that some people are still hanging around. I hope you're all more awake than I am, because we decided that last night was a good night to not get any sleep, never mind the whole presentation thing that's coming up. I'm Iain. This is Andrew. Those are pictures of us, just in case you were wondering what we look like for some reason. I couldn't bring the cat. She's also bigger than that, unfortunately. She's a terror. I'm Iain. I've been a pen tester for 8 years now, mainly specializing recently in strange Kubernetes pipeline things.
And hi, I'm Andy, founder and CEO of Control Plane. I've done my own share of pen testing and broadly full stack engineering with a lot of security focus.
So, what are we going to talk about today? Hopefully most people here are vaguely familiar with the term offensive security, but if you're not, we're going to quickly define that. We're going to talk about some common findings that we get on pen tests. By common, one of the things we're going to talk about I have found on 100% of pen tests that I've performed in the last year. Literally all of them. I've got cluster admin in less than half a day on each one the same way. We've got a couple of demos. Hopefully they work. I definitely didn't spend the last day rewriting them because I lost them. We're going to talk about some post-compromise activities, which is an area that I've seen discussed more lately, but not as widely as I would like. And we have a possible bonus demo, which is really flaky because it involves a lot of random code that Claude threw at me this morning. So we'll see if it holds up.
Right. As we are all more than keenly aware, Kubernetes, distributed systems, these are complex things. We don't have necessarily a contiguous or traceable information flow. We're looking at asynchronous reconciliation. We are setting desired state and then praying to the robot gods that they will reconcile and deliver the thing that we've asked for. It doesn't always happen that way. How could it be more complicated? Well, potentially we have a management cluster and we have a pre-production and production. Ideally, we're not multi-tenanting different data classifications on the same cluster, because that would be crazy. Or are we? Because bin packing means that we're going to save a lot of money operationally if we can get everybody running on the same set of nodes. These eternal questions don't necessarily have a right or a wrong answer. Everything, as always, is a compromise. But the reality is, Kubernetes is all things to all men. You can run a telco, you can run a mom-and-pop shop, you can run internet key signing infrastructure. So Kubernetes, by definition and by trade, is very complicated. How complicated? Well, those moving parts, what about the release window? Is my API still in beta? How long before that upgrades and breaks everything? Rapid changes, we've moved to a different release cycle, but there's still that fundamental question of, am I going to upgrade this cluster in place, or am I going to red-green my entire organization so that I can deploy to a new cluster? Am I using a service mesh? Do I have Flagger or Istio doing progressive delivery releases for us? Differing organizational, operational rather, requirements. Am I working under regulation in a financial services organization? Or again, am I just hosting my cat GIF API? And then, of course, security. Who cares about security? Well, we do. Offensive security is the way that we engage with our clients in order to meet somewhere in the middle. So we're not doing point-in-time pen tests and just saying, rubber stamp, cool, you were good at that point with that exact configuration, those exact users in the system. We're working in a collaborative way to essentially purple team. So what this means is performing a test, working with the detections portion of the business. That's a security operations center. It's the person running the cloud account that's getting those detections and audits, and making sure that the detections last beyond the piece of work that we're doing, so that when somebody else maybe runs malicious commands against that infrastructure, the company that have undertaken that purple team activity have all the alerting and they know something is currently going very wrong.
So to take that slight step backwards, penetration testing is kind of the first interface that a lot of organizations have with us as an offensive security team. It's effectively aggressive QA. So you think your cluster's secure, you think everything's okay. I come in and go, hey, I'm going to do that thing. 2 weeks later, I've done that thing, and suddenly I'm cluster admin, even though I'm only meant to be a developer. So it's a really nice kind of, maybe not entry point as the first thing you're going to do, but definitely as we need something security related before we go live, for example. Basically, yeah, let's just validate that you are as secure as you think you are. But once you've done that, what do you do next? I have had a few customers over the years who want the same test year on year, and it's really boring because nothing changes. So I'm a board consultant. The customer's paying quite a lot of money to get the exact same reports they had last year. Nobody's really learning anything or getting better value for money. Purple teaming is something we are seeing an uptick in. So this is, I'm sure we're all hopefully familiar with the red team being the offensive side, the blue team being the defensive side. Purple teaming is originally just where those kind of mix in the middle. This is much more collaborative, working more closely with customers. So a consultant like me will come in and sit down, ideally in the same room as the people who would receive alerts if something malicious happens in cluster, and actually do something malicious in the cluster. We have varying success with these engagements. Sometimes we show up and literally no alerts fire, and you say, right, how are you getting your audit logs? And they go, oh, we don't have any auditing on. So, well, what did you expect from this engagement? You're not going to find us. Other times we end up having to do really, really clever manipulations of existing attacks. So we try a technique, it immediately gets detected. What happens if we do that technique? The same thing, but just slightly differently. My favorite example is if you pick up someone running nmap in your cluster, what happens if I rename nmap as Dave and then just do /Dave and then the exact same command? Almost every endpoint protection and cluster monitoring solution I've found doesn't alert on this, which is quite funny to me. Although again, behavioral detection is kind of difficult. And we're also looking at evaluating the playbooks that organizations use. So something bad has happened. What do you do now? Is it a case of you have a really nice way of isolating the node, working out how someone got in, getting them out very quickly, making sure they can't get in again? Or is it realistically more likely you raise an alert and hope someone else in the business knows what you're doing? So we do try and help out to make sure that customers have some form of response in place, and we can help them work on those. And again, test detection coverage. We know the sort of things that attackers are doing. We can tie these to things like what are Team TNT doing? And let's face it, they're cryptocurrency mining. If anyone in the room knows of a cluster compromise that you're allowed to talk about that doesn't involve someone just mining Monero, I would love to hear from you, because every write-up is, we got compromised, they were Bitcoin mining. Like, great. Can we have something more interesting, please? Attackers out there, up your game. I want to see something cool. One of my favorite scenarios is an assumed breach. So you have a developer. Let's just assume that I've somehow compromised them. And yes, this is kind of somehow Palpatine survived, and I don't really like that. But at some point, someone's going to get phished. You're going to pull in a malicious dependency. Something bad is going to happen. Let's work out what you can do from there. The answer is normally quite a lot, unfortunately. But these are really fun engagements, because realistically, at the moment, in 2024, most clusters, if it's just Kubernetes, especially if it's a managed service, probably isn't too insecure on the internet in general. If you still have the insecure API running and internet facing now, I hope that's a honeypot. And if it's not, congratulations, you're mining Monero. So yeah, assumed breach is a nice place to start. I thought I'd disabled my notifications, but I have not. Happy days. If you're in the audience and you're messaging me on Slack, stop it. Or keep going, it'll be funny. So common findings, things we see a lot that you should probably check for. It's kind of common that we see regular findings. We see the same things again and again. This might be my favorite slide I've ever written. A foot gun is a feature whose addition to a product results in the user shooting themselves in the foot. Hopefully it won't surprise many people in the audience that my next slide is Kubernetes RBAC, because there are so many ways to shoot yourself in the foot with RBAC. We are seeing a lot of engagements at the moment where customers have over-allocated permissions, either because they just thought star is good, we'll just give you all the permissions, or because something in RBAC just doesn't work the way you think it does. It's actually quite complicated when you start diving into what is running and how the logic of RBAC gets evaluated, even more so if you've got a cluster running other authorizers as well. So if you've got node authorization, or if you've got something cloud managed or webhook-based, it gets even more complicated. And this is probably the space we see most issues in. A couple of really common issues. I had a customer, I know this is still a thing, because a customer about 6 months ago told me it's fine that they've given all of their developers list secrets cluster wide, because that's just list, you can only get the names. The customer then said, I'll prove it, I've made a secret in this namespace, if you can tell me the value, I'll be very sad. So I, of course, went kubectl get secrets in that namespace, -o YAML, I think the secret was like hello, so I replied with hello to you too, and I just got the GIF back on Slack of Homer Simpson going into the hedge. They went, oh, that's not ideal. Pod creation as well. If you know the name of a secret, but you are not allowed to read secrets, but you are allowed to create pods, you can just create a pod that uses that secret, read the value from there. Pipelines, service account permissions as well. So people like to run some form of CI pipeline, whether it's push-based or pull-based, you end up with the same problems. Those run as cluster admin. So if I just put a malicious manifest into your CI, I say they run as cluster admin. They shouldn't, but they quite often do. People don't tend to restrict the permissions much. So you can just get the CI to create something malicious on my behalf. And a lot of the time it might be that that is running in a single namespace or in some kind of isolation, or there's some kind of approval process. But there are often ways that we can get past anything like commit approvals in Git. And also, people giving RBAC star. A lot of people think star in RBAC means create, read, update, delete. How many people are familiar with the escalate verb? Couple of people. Cool. Escalate's quite cool. There's a check in Kubernetes that prevents you from creating, even if you can create roles and role bindings, there's a check that prevents you giving yourself more permissions than you already have. So if you've got namespace admin, you can create a service account binding that lets you just get secrets, for example. You're giving a service account permissions you already have. But if you, as the entity creating the object, have the escalate verb, then you're actually able to bypass that check and assign permissions that you don't necessarily have. So RBAC star isn't just create, read, update, delete. It also includes a couple of other verbs, but RBAC is the dangerous one. This QR code is not a rickroll. I was tempted. This is a RBAC good practices guide on the Kubernetes documentation. It's basically a place that a few people have gone, we've seen dodgy things in RBAC that shouldn't be done. Let's just document them somewhere so that when customers do it, I've got a link I can put in a report and say, it's not just Iain saying it's bad, it's the Kubernetes documentation. Never mind that I did the commit that put the thing on the docs, but it looks official.
So the biggest problem here is, as an application with a web-facing socket, if I want to interact with anything else in the Kubernetes ecosystem or in the cloud ecosystem in which I'm deployed, I need an identity. This is what RBAC is. It's the binding to that identity, that service count, and that used to just be a Kubernetes concept. But at the point that you want to start spinning up cloud infrastructure or accessing an S3 bucket, then you can bridge through into the permissions in the cloud and link it to that service count identity. So what's the worst that could happen? Well, potentially if you've got a web-facing socket and you're running your own HTTP infrastructure or application, and there's a bug in that code that means I, as an attacker, can make a request from inside that pod. That means that I can get the identity of that pod with the roles that are attached to that identity and potentially start kicking around in the cloud infrastructure. Well, what's the worst that could happen? That web-facing socket enables an attacker to get into the pod, to get into the cloud infrastructure, because potentially it's overprivileged or it's just using the permissions that it was given in the first place. If I can take over your organization's account from a web-facing socket, we're into existential business risk territory. And the simplicity of the fact is, it is just the RBAC on these things. It is the permutations of configuration and the interplay of these different systems that is our first line of defense against a breached pod. And the sensible thing to do is assume that everything is always broken, and assume breach means architect your topologies and tighten your configurations on the basis that a malicious insider or outsider is already in your pod kicking around with your cloud infrastructure. And half the time, it is actually Iain.
Can confirm, at least once, it's been me. So let's see if this demo is going to behave itself. I have here an Argo CD instance running in a kind cluster. I should say quickly, this is not me saying Argo is vulnerable to anything. This happens with all of the platforms. It happens with every CI. The same things can be done. I just like having a pretty UI instead of just having to use kubectl commands all the time. So what we've got here is a deployment that is currently not able to deploy because I'm running in a restricted namespace. The namespace that this is deploying into is labeled with pod security standard restricted, so pod security admission is not letting the standard Nginx pod run. I am also, this Argo project has been set through Argo's RBAC, try saying that 3 times fast, to only be allowed to deploy into a single namespace. This is not running, the service account that is creating resources has cluster admin, but Argo's application logic is saying we're only allowed to deploy in one particular namespace. I have a kube config for the developer user, and in the namespace let myself in, I should only have the permissions that are allocated to system authenticated. So these, hopefully you're fairly familiar. If you've never seen this command, by the way, and you're ever playing capture the flag competitions in Kubernetes, kubectl auth cani -- list lists all of the things that you're allowed to do, with some caveats, assuming that the cluster's only using Kubernetes RBAC. I'll happily talk for quite a while about that later if you want. This basically gives you the permissions you're allowed to do. If you're doing a capture the flag, possibly like the ones that control plane occasionally runs, this is a really useful command for working out where to go. It's also useful on pen tests. But I have basically no permissions as the developer user. I'm going to just demonstrate that there are some restrictions in place. So I'm going to add a cluster role binding for my user to cluster admin. I'm going to add a role binding for my user in kubesystem. And I'm going to add, I'm going to try and relabel my own namespace. And what we should see when this syncs, I'll just force it to sync a little bit faster because otherwise we'll be here all day, is we get synchronization failed. We have 3 messages. This might be quite small. We have 3 messages. One says you're not allowed to modify namespaces. One says you're not allowed to create resources in kubesystem. And the other one says you're not allowed to create a cluster role binding. So happy days. This looks like it's a reasonably good setup. But what I'm going to do is, first of all, confirm that I've not magically got any more permissions, which looks the exact same as it did before. And then I'm going to remove those resources and create a new resource, which is a role binding to the cluster role cluster admin. A role binding only allocates permissions in a single namespace. So this will give me admin access in that one namespace. I think I just need to tell Argo not to do this. Argo's funny. Sometimes it just, if it fails, it keeps trying to apply the synchronization, and then you fix the resources and it doesn't know, but we should be good here. So what we have now is a developer to cluster admin role binding, which has given the user developer cluster admin, but again, this is a role binding, so it's only in a single namespace. I'm now just going to list my permissions, and you'll see here I've got star.star, but again, only in one namespace. If I don't have this in my demo magic, but if I ran this command in kubesystem, I would not have any additional permissions. The thing that's really weird, and I was surprised when I found that this worked, is if you have the ability to patch a namespace in that namespace, so if I have a role binding that says, yes, you're allowed to patch a namespace, I can actually label my own namespace from inside it. This doesn't seem right. It's really bizarre, and I had to check this like a lot of times when I sent this manifest to a lot of people when I first found this. Basically, namespaces are sometimes cluster-wide, and sometimes they are namespaced. But I can now just relabel my own namespace as privileged because Argo is running as cluster admin. It's given me the permissions in my namespace, and I can take advantage of those to relabel my namespace. And with that, I can restart my deployment because sometimes this just takes a couple of minutes. And what we should see is that I have pods running. Happy days. I have 1 pod in my demo deployment up and running. And the image will pull, and it will all be. There we go. We actually have 3 now. And Kubernetes will do its magical thing, and we'll go back down to 2. So at this point, I'm actually able to create any resources. I'm labeled with privileged. I have a demo that I'll come back to in a couple of minutes that will let me get cluster admin at this point. But before we do that, I want to talk about persistence. Do you want to talk about this? Or actually, I want to make Andy talk about it. This will be fun.
Right. Once one is into a cluster, there are many ways to try and establish that persistence. The exfiltration of credentials that allow external access in some way, the installation of something like a cloud-native rootkit. So what can I do that will relay my access in a persistent and potentially invisible way? There is a whole lot of nuance around whether or not the container running as a shadow pod in the container D namespace. Did we actually find the answer to this out yet?
We have a couple of answers. I'll come back to that in a minute.
Yes,
yeah.
we're into, it's not quite debating the gender of the angels, but who runs the container if the kubelet and container D are fighting over an individual pod. Can we hide that from the Kubernetes API server pod lists? Well, it transpires that you can. So these post-compromise activities may be within the cluster. It may be just repeating the same path into the application. So maybe if you've got a vulnerable version, making sure that that vulnerable version stays deployed. It can also be that escalation to the cloud account. If I can then exfiltrate some keys that give me access, so I'm not going in through the application, through the API server, through the IAM endpoint and into S3 or EC2 or whatever it would be, thank you, then, well, can I just start another server that then runs on a public IP in EC2, for example, and then into that cloud account, potentially I can then go and create a snapshot image of part of the running cluster. That's then exfiltrating data in a persistent way. Within the cluster itself, direct etcd access is a particularly fun one because over the years, etcd has changed how it interacts. etcd 3 is now all proto-Buffy flavored, and it's possible to write a pod into etcd and have the API server say, oh, there's a pod without a node, let's give it a node and deploy it, bypassing all the admission. Now, of course, we should be installing our client certificates, making sure that etcd is encrypted in transit and at rest. There's multiple layers of certificates that we can use. But again, it's a subtle way into a container. Crafting service account tokens, this is minting more credentials for ourselves within the cluster. Custom RBAC, as we've seen, we can list those roles, but actually everything should be coming from a GitOps repo. We should have configured the entire thing, and the creation of those roles should be reverted if they're done manually, so that we don't get in this situation where attackers can determine their own persistence. And yeah, the malicious admission controller is a wonderful one. That was from KubeCon LA, I seem to remember. Ian Coldwater and Brad Giesman, just installing crazy admission controllers and demonstrating that you can persist using part of that critical control plane infrastructure. And static node manifests. We've been debating this for a little while.
Yeah, so for anyone who's saying, oh, these sound really dangerous, but you need to be admin to perform these attacks, things like direct etcd access. If someone on the internet can talk directly to etcd, that's game over for your cluster, 100%. That should never be the case. And it's actually really difficult these days to make that even possible. The point that I would like to get across with this is, can you get rid of an attacker once they're in a cluster? If you find out that someone did at some point compromise one of your users and you suspect they got cluster admin, how sure can you be that you actually can get them out and be sure that your cluster is clean again? Because the blast radius of a compromised cluster is all of the workloads on that cluster, all of the credentials and all of the services that cluster can communicate with. So if you've got databases that you've got passwords for, all of those passwords need to be rotated. In Kubernetes, there's a bunch of ways you can get persistence. Static node manifests are a fun one. You can actually create a static manifest on a node that is in a namespace that doesn't exist in Kubernetes. The pod will run as a workload on the node, but you'll never be able to see it through kubectl. So as a defender, you need to be aware of all of the places that services can be running, processes can be running, anything can be started, and know how you get observability into those, because it's actually fairly easy to create workloads that don't show up in kubectl or look completely normal, but actually are something malicious. And if you forget about all of the fancy serverless stuff and all of the Windows nodes are just Linux. So all of the things that attackers have been doing for quite a long time now still work in Kubernetes environments. If I compromise a node, I can create a cron job on that node, I can drop my SSH keys on, I can modify the container runtime. When I first proposed this talk to Andy and we were discussing some of the things you could do, he was saying, that's easy, if you compromise my node, I'll just detach all of my storage, rebuild the EC2s, and then attach the storage volumes back in again. But what if I found a way of actually persisting by modifying behavior in a web app, for example, and you've detached all of those volumes, rebuilt your cluster, but then you just reload the code that I modified? So being sure that you've got rid of an attacker is really, really, really tricky. And I hopefully have a demo that shows how quickly some of this can happen. I've had customers that say to me in the past, I had a customer ring me up at one point and say, hey, we caught you doing DNS exfiltration in our cluster. So that was great, but the job was 4 weeks ago. You're messaging me now, really proud that you've caught me, but think about how much data I could have just hoovered up over that time. Oh, I've got an alert to say that someone's broken into my cluster. When? January. But, okay, but they've been in your cluster now for however many months. What month are we in? October. 10 months, something like that. I have a script here that shows how quickly this can happen. So basically what I'm going to do is create a privileged pod, and I bet you this script doesn't work because I've forgotten to do something, but you can see what I'm trying to do anyway. I'm going to write an SSH key to the root user. I will see if I can remember how to make this bigger. There we go. I'm going to grab etc Kubernetes superadmin.conf. Superadmin.conf confused me. Admin.conf isn't actually the most highly privileged role, kubeconfig that's created in a kubeadm cluster now. Superadmin.conf is. It still has the same problems of admin.conf in that it's a hard-coded client certificate for system masters. It's just named differently now. I'm going to grab pki ca.cert, and if I grab ca.key as well, I could sign my own certificates for this cluster. I'm going to send some data back to my attacker node, which I hope is still listening there. And I'm going to copy a static manifest in. We'll see if this actually works. Hopefully, we're going to create a manifest called root.yaml. Root.yaml is basically an implementation of the most pointless Kubernetes manifest ever. What it basically does is create a pod on a node that has all of the host resources, mounts the host file system. This is why all of my file paths in here are /host/etc/Kubernetes, because /host is where the host container is. Now, hopefully, where the host file system is in that pod. Hopefully, that pod is running. kubectl logs. And interestingly, my listener didn't actually update and print out, so I suspect that SSH session has died. But you can see that all of these commands ran. I've got here all of the things I would need to get some level of persistence in cluster. I was writing this earlier and thought I could put 20 or 30 methods in here just to really prove the point, and then went, actually, that's kind of pointless because it's just more text to scroll through. My point here is, if your response time is faster than any customer I've seen, and you're fairly sure that you can detect a compromise in under 2 hours, I can do all of this in 10 seconds. And yes, you can probably quarantine nodes, but I can have exfiltrated data, assuming you don't have things like firewalls in between your environment and me, and so on. I can do an awful lot of damage very, very quickly. So as a take-home exercise, there's something that I would encourage everyone who manages a cluster to have a think about.
Yes, wonderful. So in the event of the canary in coal mine situation, in the event of a gas leak underground, the canary is there because it is sacrificable, and unfortunately, the canary pays with its life in order to keep everyone else safe. Canary tokens are the digital implementation of those poor birds. So what it's possible to do is using canarytokens.com, or thanks to Canary, who build a hardware version of this, it's equivalent to a honeypot. These are credentials that, when they're used, fire an alert. So you can put these credentials as HTTP listeners into PDFs. You can put AWS keys. Unfortunately, Trufflehog decided to enumerate all the AWS accounts that are being used. So the AWS ones are slightly less useful at the moment. But this is a Kubernetes honey token. So the purpose here is, on production clusters, sprinkling keys that should never be used and giving them very attractive names for attackers is the last line of defense. Nothing is entirely secure. Even with the best architecture and defenses in the world, we can't prove that there are zero days in the infrastructure. The Linux kernel itself, many million lines of code, millions, and guaranteed to still be harboring CVEs that will melt the internet at some point soon, today, next week, year. So nothing is entirely secure. So we have preventative controls. We're running static analysis on things that get deployed to our clusters. We're enumerating our RBAC. We're running detective controls. We are trying to identify when these things are heading out by maybe turning off what am I trying to say? But running split horizon DNS so that anything that goes externally can actually be analyzed, and we've got as much locally resolved. And we can run remediative controls that detect those things and try and drain nodes and shut down, basically preventing data from being exfiltrated. Even with all of those in place, we may still not know when a nation state is running through all of the ISPs in the country, as happened to the US last week, or running through Guam, all the submarine landing cable points again. the detection is as important as the rest of the pieces of the puzzle, because we can never fully isolate, close, and make something watertight and entirely secure. These things are absolutely wonderful. I recommend they're completely free. You sprinkle them liberally across your estates, and watch out when Iain starts using them. And that is perfectly on time, unbelievably, the end of the talk. Thank you very much for your attention, and feel free to come and pester us afterwards.